The Elements, a visual exploration of every known atom in the universe. Today we're starting off with number 56. This is the last element before we go into the lanthanides. Barium itself is the last element in the periodic table until we just go ahead and have to split it up, put it down at the bottom, and we go to the lanthanides. Note that you probably noticed that the lanthanides are named after the element's name, lanthanum. But we're on barium right now, so let's talk about barium. Barium is from the Greek word for heavy. Yes, I am not joking you. It is from the Greek word for heavy. Although, surprisingly, it is not heavy. It is way less dense than titanium, which is a metal that is known for being light. While barium itself is not heavy in pure form, the same cannot be said for its alloys or compounds of it itself. You can go ahead and take advantage of all those barium compounds in different ways. You can almost find barium in almost all common vacuum tubes that contain barium of some kind of sort. There's a large patch of metal in some of them that's flashed onto the inside of a glass envelope in some of the vacuum tubes. And little warnings though, when you're trying to ship barium, you're going to have to put them in some sort of can, mainly because, well, unless you want to try to clear the whole planet of oxygen. Other than that, there's not that many applications towards it. Its atomic weight is 137.327, its density is 3.510, its atomic radius is 253 picometers. Its crystal structure, it's a very stable cube, at least what I mean by stable, you'll probably understand. It has skipped all the way to 6s again. Has a moderately low, for metals at least, melting temperature, a moderately low boiling temperature. And now it's time for everyone to go ahead and split themselves, and now we're going to the lanthanides, which we will be stuck into for like the next 3 episodes. We will exit it on the 4th episode. Lanthanum is number 57. Lanthanum is the first of the rare earth series, even though they are not rare. They are from the earth, so. And they are known as the lanthanides, the uppermost of the 2 rows that are at the bottom of the periodic table. All of the lanthanides are chemically almost identical. They are all found together in the same ores. Yeah, that's one of the rare exceptions. In fact, it took years for some scientists to figure out that what they thought was one chemical was in actuality several different chemicals. Several different lanthanides. Their main differences are in their magnetic properties. Some rare earths are more magnetic than the others, which really aren't rare, I should mention again. Some rare earths like neodymium make the strongest magnets, while terbium-65 are just alloys that change shape in magnetic fields. They have different tendencies to be magnetic. As for lanthanum itself, it is one of the most abundant of the rare earth metals, which aren't really rare, and it's used in many applications. One of those examples is one of those lighter flints. You can add them into one of those flint and steel stuff, and you can create flint pretty easily. Lanthanum oxide glows brightly, and that's why they're using them in camping lantern mantles. That's one of the reasons too. And there's this mineral bastanite, which people took a very long time to realize that was lanthanum and cerium, and sometimes drastic showers of sparks are created by holding a misgeneral block to a grinding wheel. Yeah, you can't do that. For some reason, the author did that. Rare earth oxides are really heat resistant, I should mention, and that's why they glow brightly, making them useful for camping. Or lights. Next, atomic weight. We have 138.9055, the density is 6.146, the atomic radius is 195 picometers, and its crystal structure, it's a hexagonal prism. And it has a pretty moderately high level of melting point compared to metals. It has a really high level for boiling point. And yeah, I think you get the rest. 6s has finally been filled. I'm pretty sure this part is going to be filled now. 4f is empty. The atomic emission spectrum should be a bit more varied by now, I was guessing, but no, it's not. Number 58, the next one, it's cerium. Sounds a lot like cesium in my opinion, but it's unfortunately not explosive. Cerium is almost as abundant as copper and is quite inexpensive, especially in its form of cerium oxide. You can guess it by adding cerium and oxygen together. Especially in that form though. It is widely used in the abrasive powder for polishing glass. You can polish glass with cerium, Cerium metal can catch fire when you scrape, file, or grind it, which makes it really useful for flint and steels, but I'm guessing that they would rather use lanthanum for that. In practice, this doesn't mean that a bunch of it will just light up in fire, but rather that the shavings burn as they are formed, making this material very sparkly. So if you go ahead and scrape it a lot, you're going to result in a lot a lot of sparks and fire. Once again, it took them a while to realize that this was one chemical instead of several other ones. Its atomic weight is 140.116, its density is 6.689, its atomic radius is 158 picometers, and its crystal structure, it's a even more stable cube, at least what I call more stable. As I guess 5D is starting to be filled, 4F is starting to be filled too. It has a moderately low melting point. It has a moderately low, okay, it's medium high of a melting point, of a boiling point too. Next up, 59, we have praseodymium. Praseodymium is one of the interesting names, in my opinion. It is named after certain things, Praseodymius. I would say April Fool's, but then I just realized that April 1st is gone. When you're engraving the names onto your element collection, which I'm not sure why you would have, praseodymium is one to watch out for. It's the widest element name, and that is a proportionally faced front too. Rutherfordium, element 104, has more letters, but only one M. Yeah. The author knew this maybe because he was trying to build a periodic table out of wood. Periodic table out of wood, and realized that praseodymium would not fit. Many rare earths are not rare at all. They just got that name mainly because they're very difficult to separate into different parts. Even though the differences are pretty small, it's really difficult to separate them. It took scientists a while to figure out that, well, they're different elements. What is praseodymium used for, though? Well, apparently you can use it to make blue filters of light bulbs. You can turn an inefficient yellow incandescent bulb into an even less efficient daylight spectrum bulb. Why would you do that? Don't ask me. Praseodymium creates the color in fake cubic zirconia, which is it's basically just used to create colors as well too. Rare earths were even given out as sample sets, mainly because just to show that rare earths are no longer rare, and they were suddenly reasonably priced. And they are used to create daylight white motion pictures. Its atomic weight is 140.90765, its density is 6.640, its atomic radius is 247 picometers, and its crystal structure, it's that. It's a hexagon. What did you expect? It has a moderately medium melting point. It has a moderately medium boiling point as well too. As I predicted, 4Fs are going up. What I didn't predict though is that red is concentrated in the atomic emission spectrum. And finally, before I called it a day, we have neodymium. Neodymium is the best known of the lanthanum series of metals of rare earths, mainly because of neodymium magnets, which are in reality made out of iron-boron alloy, including neodymium itself. And they are by far the strongest readily available permanent magnets that you can ever know, so far created by mankind. They can jump towards each other a foot away. Their magnetic fields are that strong. Even a small one can give you a blister, and large ones will definitely kill you. So never ever grab neodymium whenever you have like another piece of neodymium nearby. If it's at least a foot away, well, boom, you're dead. Especially if you're carrying a large sample. They're so strong you can even wear them as a bracelet without needing any beads or something to hold them together. And strong neodymium magnets are so strong that you can just go ahead and hold earrings on them without needing to pierce them. That would be really useful for some people who really hate piercings. And since motors are using magnets inside them, you're going to have to go ahead and use neodymium magnets inside them to make them even more powerful. Practically, the only use for neodymium is to create really ridiculously strong magnets. Its atomic weight is 144.24, its density is 7.010, its atomic radius is 206 picometers, its crystal structure, it's a hexagonal prism, and it has about 1,000 degrees of a melting point, and it has 300 degrees for a boiling point. It has a technically middle balanced version of the atomic emission spectrum. 4F is starting to come up, and I really hope it fills the whole table by the time we finish this. And that is it for today. I hope you guys enjoyed this episode. I hope to see you guys soon. Until next time, Shnan out. Peace. Bye-bye.